Hypothesis testing. Hypothesis testing is a key procedure in inferential statistics. It is based on the idea that we can tell things about a population from a sample we take. It can be explained in 5 steps. Step 1. Decide on your hypotheses. You need a null hypothesis and an alternative hypothesis. Inferential statistics is based on the premise that you cannot prove something to be true, but you can prove the opposite to be false by finding an exception. So it can be said that the alternative hypothesis is the thing we are trying to prove. Note that the hypotheses are always about the population, not the sample. Step 2. Decide on what level of significance you will reject the null hypothesis at. Unless there is a good reason not to, people generally use 0.05 as the cutoff value, also known as the alpha value. This is the probability that you will say that the null hypothesis is wrong when really it is correct. Step 3. Take a sample from the population to provide the statistics you need. Step 4. Calculate the p-value. This is almost always done by a computer package these days. Step 5. Use the p-value to decide whether to reject the null hypothesis. If the p-value is less than the alpha value you chose earlier, you will reject the null hypothesis. The sample has given you evidence that the null hypothesis is wrong. We will now go through this step by step with an example. Helen sells Choco Nutties. Her brother is taking a marketing class and tells her that people will buy more Choco Nutties from her if she gives away a free gift with each packet. Helen is skeptical, so she decides to gather data to see if it's true. She decides that for the next month she will try out some days where she offers a free sticker with each packet of Choco Nutties and some days when she doesn't. From this month of trials she will have a sample that can be used to draw conclusions about days in the future. The population in this instance is all days of selling Choco Nutties. The sample is the days that occur in the next month. This is not a random sample, but it's all we can do in this instance. To make the assignment of sticker or no sticker in a random way, she will toss a coin each morning, and if it is heads, Helen will offer a free sticker. She'll keep track of her sales for each day. She asks you to help her do the analysis. The first step is to decide on the hypotheses. There are 2 different circumstances, sometimes known as treatments, offering a sticker and not offering. The null hypothesis is that there is no difference in the sales for the 2 treatments. The statistic of interest is the mean or average value of daily sales. So, the null hypothesis can be written H0, there is no difference in mean sales for the population for the 2 treatments. The alternative hypothesis is written H1 or HA, there is a difference in mean sales for the population for the 2 treatments. Helen thinks the sales could go up or down as a result of offering a free sticker. Written in mathematical terminology, we use mu, a Greek letter to represent the population mean. These are the mean sales for all days that Choco Nutties are ever sold. These are different from the sample means, which are the values we calculate from our data. The subscript, saying either free sticker or no sticker, indicates whether we are talking about the population mean for days when a sticker is offered or when it is not. So we have H0 mu free sticker equals mu no sticker, which then rearranges to H0 mu free sticker minus mu no sticker equals 0. And the alternative hypothesis, H1 mu free sticker doesn't equal mu no sticker, which rearranges to H1 mu free sticker minus mu no sticker is not equal to 0. So that's the mathematical way to write the hypotheses. We do not know what the values of the population means are, but we are going to use information from the sample to get sample means, which will then help us to make inferences about the population means and the difference between them. There is a not equal to sign in the alternative hypothesis, as we are interested in differences from 0 in both directions. This is called a two-tailed test or exploratory hypothesis. If Helen was sure that the sales would not go down and was only interested in whether they went up or not, the hypotheses would look like this. This is called a one-tailed test or a directional hypothesis. We'll stick to the two-tailed test for now. The second step is to decide on the level of significance. We choose alpha equals 0.05. In the third step, Helen goes ahead with her plan and provides 23 days of sales figures, 13 of which were when she offered free stickers and 10 when she did not. You put them in a spreadsheet and use Excel to draw histograms of the data and calculate the appropriate p-value. The process for doing this is shown in a separate video called Differences Between Means in Excel. The results look like this. The mean sales for the free sticker days is $301.92, while the mean sales for the no free sticker days is $265.83. There does seem to be a difference. For step 4, you see that the p-value for the two-tailed test is given as 0.019. Step 5. The calculated p-value of 0.019 is less than alpha, which we decided was 0.05, so you reject the null hypothesis. Helen would like to know what that means, so you explain that the data she has collected indicates that there is a difference in mean sales depending on whether you offer a free sticker or not. Important points to remember. The hypotheses are made about the population. We collect sample data to draw inference about the population. We know whether there is a difference between the sample means. We use information about the samples to decide, using the p-value, whether there is evidence to say that there is a difference between the population means.